Hello and welcome to this screencast about double calculator. My name is Pranav. In the previous iteration of this calculator project, we saw an integer calculator that was able to perform computations on integers, meaning whole numbers that are in the set of capital W, you would say, starting from 0 ending up to positive infinity. And and you also had the negative numbers from -1 till negative. So it was the set of integers capital Z, if you will. In this iteration of this calculator, we have changed the type of the number from integer to double value, meaning you can actually add decimal points and exponents in your computations and use them according to your needs. And we also have a square root functionality added that will let you compute the square root of any given number. Plus we have some customized error reporting that will help the user to avoid entering any unnecessary values or uh, you know uh, garbage values into the calculator that might hamper the performance of the calculator. You will see about the error reporting in a while. Plus, our customized error reporting that we have developed runs on something known as a finite state machine. Finite state machine is a deterministic finite automata that has a start state and an end state and a series of states in between, and it is guaranteed to parse a given input and tell whether the given string is a part of the grammar that's been developed or not. It is a formalism to check for vocabulary of a particular grammar. So I'm currently wading into the natural language part of that and Chomsky's context-free grammar and all of that. So that's not the portion of the discussion I would like to further iterate on. So coming to our regular calculator, let's just run it and see what it does. And here we go. So it compiles successfully without any errors, and so this is a double calculator. You can see the interface hasn't changed pretty much. I'll be added as an extra button and some error reporting. And let's try doing our regular operations with regular integers. So I'm going to do 25 and 10 and add them, subtract them, multiply them, divide them, and uh, mind you, when you click on the square root, it actually computes the square root of the first operand. So if you want the square root of 25, you click on that, you get 5. But if you want the square root of 10, you have to go back to the first operand and then click on square root, then you get the square root of 10, right? Now we also added support for the exponent based calculator, that is a number followed by an exponent plus or minus some value. Say if I want to enter 2.5 and I say E, then it suggests that the next character should be a digit, a plus or a minus. So if I write 2.5 E2, that means that this number is equivalent to 2.5 into multiplied by 10 raised to the power of 2. So that's 2.5 into 100. So that's 25 by 10 into 100 cancels 250. So that's 250. And now when I do the same thing, say I want 4.6 E7, it shows the same error message. If you go back a step, that the number after the character that should be entered after an exponent symbol should be a digit, a plus or a minus. And I write this. Now this is equivalent to 4.6 multiplied by 10 to the power 10 raised to the power of 7, or 10 to the 7th power. And if you wish to perform any computations on this, say plus, it does that and gives you the answer in terms of the exponent. If you want to subtract, if you want to multiply, if you want to divide, and if you want to take the square root of the first one, 250 square root, and well, you have that as well. So we have our customized error reporting as well. And let's check some more things that we can do in terms of the error reporting. If you enter something other than a number, say I enter a string, I enter my name, then it automatically throws an error saying that the first character should be a digit or a decimal point, right? So this is one more customized reporting. And we also, if you want to enter a number that's less than 1, say 0.5 or 0.75, you can just type that in a plain vanilla way, like 0.75, or you can simply just write 0.5. That's it. It's as simple as that. You can perform any operations on this, and voila, it checks up. And last but not the least, you can actually use plus or minus with the actual exponent term. I'm sorry, say 9.6 e plus 6 and 5.1 e, I'm sorry, 5.1 e minus 4. And if you do that, this will have your results pretty much the same. Coming to the logic behind this calculator, we actually have a basic user interface class, that's this user interface.java, that contains all this UI elements like this, labels for this text fields and these buttons, and the methods that are actually called when they're actually pushed are written in the backend of the business logic portion of the program. And one more error reporting term that I forgot to talk about is square root for a negative number. Say if I write a simple minus, it automatically says that negative numbers are not allowed, because if you remember, it's the first operands text field that actually is used when you call the square root function. If I write -5 and call the square root, it says not a number. But if you see, if you write a negative number in the second portion, and then you obviously have the results dished out for you, right? So that's the portion of the results. So that's our calculator in brief. That's about the calculator in brief. As I talked about the various advantages of using this calculator over your conventional handheld calculators, obviously number one, the thing that comes to mind is cost, because this is written in Java and that's open source till JDK 10, mind you, and we are using JDK 10 and that's still open source. So this software costs next to nothing. It's portable. All you have to have is an executable, a jar file of all these classes put together into a single jar file executable, and you can run that. If you have that in your cloud or a network attached storage NAS, you can access this software from anywhere in the world. And in the later iterations of this software, you'll be having an ultimate precision values and also error terms, and you'll also be able to add to physical quantities like to lengths or areas of two objects or volume of two objects or speed of two objects. You'll be able to perform all those operations which current generation scientific calculators don't have the ability to deal with. So I think this is a cutting edge piece of technology, and obviously it's very useful, very robust, very secure, and it's simply to put, it's a great piece of software. Thank you.